Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back in lecture 5. Student, basically, as we are in lecture 4, we cover this table. Okay, how we fill up this table. Okay, the whole calculation is explained. And one thing I want to share with you, that remember, here we have two restrictions, that our area of steel should not be less than S minimum, but at the same time you have to make sure that your spacing should not be more than 11 inches. Okay, so that's why here the controlling criteria A for A is 0.22, because if we provide bars, number 4 bars at a rate of 11 inch center to center, it gives us this much area. Okay, so that's why A is basically controlling here, because if we decreasing the A is provided value, okay, it will increases the spacing. Okay, it will increases the spacing. For example, if we provide as minimum, it will produce 20 inches center to center spacing. So that's why we are not using that 20 inches. We are bound to 11 inches. So the question is that if we provide such reinforcement in which we are using number 4 at the rate of 11 inch center to center, which gives us A is equals to 0.22 square inches. Now what amount of movement capacity will be produced by this steel? Okay, so the formula for this is, I write here. Okay, this is the formula. I already explained this formula in my lecture series, frame structure analysis, manual frame structure analysis, which are available on my YouTube channel. Okay, so here we have 0.9 ASFY into D minus ASFY divided by 1.7 FC prime into B. B is 12 inches. D is you can see here 4.5, and all thing you just plug the value, you do the calculation, you got 51.53. Now if we provide this amount of reinforcement 0.22 square inches, it will give us a design capacity of flexure capacity, that is 51.53. Now you search those movement capacity. Remember, 51 is more than this one, so this steel will work for this movement. 51 is more than 31, so this reinforcement will also work for this. Okay, similarly 51 is more than this one, so that's why we are providing number 4 at the rate of 11 inch center to center, and you see here. Similarly 51 is more than this one, so we same the case will be here. And similarly 51 is more than this one and this one as well, so that's why number 4 at the rate of 11 inch center to center. Clear? So this is the reason why we are using the same amount of reinforcement. This is another table. Okay, I basically summarize all the things in one table. Okay, this is the way how you can minimize your time, how can efficiently you design a slab system. Okay, the whole calculation in a one table, you see. Okay, negative movements, and let us check these calculation in Excel sheet, but I will check it. Okay, let me find out the Excel sheet where that Excel sheet was. So this is an Excel sheet the developer in the front of you. Okay, and let us check its Excel sheet whether it is work or not work. Okay, so here you see that the Excel sheet will be looks like in this shape. Clear? Now you see here how to use this Excel sheet. Okay, let us check it. Clear? So here you see your short span. So let us checking the panel A. The panel A short span is 18.87, I think so, 18.875. Clear? Let me check it. Where is here we have this one, 18.875. Clear? 18.875. This is the short span, and the long span is that is 18.93, okay, 9375. Clear? So this is the long span of panel A. Okay, this is for panel A. Clear? So remember, this is due to rounding effect. Okay, now in panel A, basically if you search here, in panel A, basically you see this edge is discontinued, this edge is discontinued, this edge is discontinued, but only this side is continuous. Okay, so that why I check this one is discontinued, this one is discontinued, and this one is also discontinued, but this one is only continuous edge. Clear? And let us now checking the amount of movement. Okay, first of all, MA positive, MB positive. So this is 2.28 k feet and this is 2.68 k feet. This is in k feet, remember. So let me check it. Okay, let me check it. We have a moment amount of this is for panel. Yes, this is for negative moment. MA positive is this moment. Clear? MA positive, this is 26.67. if you have a calculator, just 26.67 divided by 12, you got 2.22, which is close to, you can say, which is close to 2.28. so that's why, because the only difference why it is different, you see here the thickness required for the slab is 50, but they are basically provide 6 inches. Because this is ACI limit criteria, you cannot use thickness less than 6 inches, but we are using 5.5 inches. Okay, so here the loading is different. Superimposed dead load is basically, that is in our case, that is 38. Where it is, I will show you here. Here you see that my superimposed dead load, this loading, okay, this loading, just add up these two loading. So if I add these two, let me add up 0.025 plus 0.013775. Okay, so you got 0.038 multiplied by 1000, you got 38.75, and that is our superimposed dead load, 0.75. Clear? Sorry, 38.75. Clear? This is my PSF and live load is this much. Clear? And a concrete strength is 4 KSI, and this is okay. Now you see 2.33, and our calculated value is value for MA positive movement is let me check out here. Clear? Here for short span in panel A, MA positive value is 26.67. okay, if you divide it by 12, you got 2.22, I think so, 2.22. so this is close. Okay, this value is close. Now let us check it, this one 2.74. so here you see in long span, basically this one MB positive. Okay, MB positive, this is 31.62. so 31.62 dividing by 12, I using my calculator, I got the value 2.63, which is close to 2.74. okay, so this value is also okay. Now we can check this one, 5.79. okay, and we have 66.76. so let us 66.76 divided by 12, you got the value is 5.56, and it is also okay. Okay, 5.79 are we got 5.56. okay, this one is also okay. Now you see this one is basically 1/3 value of this one, and this value is basically 1/3 of this value. I theoretically this value and this value is 0 because these edges are discontinued, but ACI criteria says that you have to consider 1/3 for this one and 1/3 of that one. Clear? So this is the procedure how we can do the calculation for panel A. Clear? Similarly, now we can check the calculation for other panels as well. Let me check out panel C. Let us we check out panel C. Clear? So panel C is all edges are continued. Okay, all edges are continued, and the spans are 19 feet and 19 feet. Okay, yes, this problem is, so we have to change. Longer span should be greater than, let us let's say this one, we say this is 19.001. Let us it work, yes it work, this is 19 feet. Clear? So it work. So a little bit larger value, okay, this one, then Excel sheet will work. Okay, now you see that here you see the MA positive, MB positive, both are same because this is square panel. Okay, now let us check it. Here you see that 19.7 and 19.7. So if I divide 19.7 divided by 12, okay, I got 1.64, which is close to 1.7. Okay, which is close to 1.7. Clear? I got 1.64. Okay, and let me check out this value 3.69. so I have basically this one, this is in shorter direction or longer direction, but this one and this one is same. So 42.6 divided by 12, I got the value 3.55, and that is also correct because we have 3.69 and I got 3.5. So this is close. Okay, and the calculation of area of steel you see here, it also gives us the calculation of steel area automatically. Okay, so this is the advantage of Excel sheet. Okay, now you see number 3 at the rate of 7.5 inches center to center, and we basically design we are using number 4 at the rate of 11 inch center to center. Okay, for this amount of movement. So this is basically minimum reinforcement, and you see all the calculation. Okay, and similarly you see the drawing here. Okay, it will give you, and I will discuss this drawing, okay, in very detail. So this is the Excel sheet how it works. Okay, and you see all the movements are correct. Clear? This basically the calculation. Okay, now let me introduce some these factors. Okay, these coefficients, and then we basically in next lecture inshallah we will start, I will show you the detailing of the slab system. Okay, which is very important. Now you see these calculations, I basically I picked this table from Nielsen book. Okay, you see that these cut up bars locations, or you can say bent up bar locations for a flexion member. So how this is, you can see this is your negative reinforcement. It can be cut out at a distance of L1 by 4. This is a wall. Okay, and here you have a column. Clear? Here you have column, but here you have wall. Clear? Now the bar should be inserted into the wall or beam for a distance of 6 inch. This is ACI criteria. Now you see, if you are cutting a bar, the positive bar near the support, the distance should be L1 by 8. This is approximation. Clear? And it should be inserted. Okay, it should be, the rest of the bar should be inserted into the column for a distance of 6 inch. Clear? And remember, similarly the next one can be cut it, okay, the middle span of the interior span, okay, at a distance of L2 by 8. Okay, and similar is one L1 by 3, L1 by 3. Similarly positions for bent up bars. Okay, and I will use this pattern. Okay, because in slab this pattern is a little bit tricky. We use this in beam. Clear? We use this curtailment of bar in beam, but we prepare this kind of bar arrangement in slab because this is easy in slab. Okay, nowadays this kind of bent up bars will not providing in a beam because it is difficult, although it is better to provide this inclined bars because these bent up bars because it provide extra shear strength. Okay, but inshallah I will use this one. Okay, in next lecture inshallah you will see, please uh, um, understand these two tables. Okay, because the whole detailing of the slab system will be based upon this table. Okay, let me finish this table as well. Okay, once you got your movements like you see here, you need to represent those movements in this table form. Okay, on the drawing. Okay, because this is easy. You see MB negative, MA positive, MB positive movements, MB negative movements. Okay, and you see MA negative, although theoretically this movement is 0, but I consider is at 0.86, which is 1/3 of this movement. Clear? Similarly, this is, you see, 1/3, and here the theoretically movement is 0, but ACI code says that you have to consider 1/3, so that is the 1/3 of that movement. And similarly, you see all the movements which I calculated here, I represent all the calculations right here. Okay, so you understand by just looking one time that where is your movement is maximum. Remember, the looking to the beams positions are the negative beams, negative regions. Okay, over the beam slab is the maximum moment. Remember, there is the maximum moment. Remember this one. Clear? So because it will also be doubled, so this is the critical regions. Remember, these are the critical regions. Similarly, here you see negative movement is dominant. Same case here and same case is here. Okay, more critical regions. So you have to provide proper reinforcement. This negative reinforcement should be proper. Okay, proper development length, proper hooks. Okay, because this region is more critical as compared to the positive region. In positive region, you see we have minimum movements. Okay, you see here 19.7, 26. Okay, 26. So in positive region we have minimum value of movement, but in negative, this is important. This is very important because this is how we can say a critical analysis. Clear? So I hope you will understand. In the next inshallah lecture, that is lecture number 6, we understand the detailing of the slab system. Okay, and you see this whole detailing system I will, how to lap the bars. Okay, in a slab system where you have to provide lap. And one thing you must remember that on lapping, basically I recently published some videos. Please watch those videos, mistake in civil engineering YouTube series, I think so. In that playlist, basically those videos are present where you have to provide lapping in a slab system or beam. Okay, in beam. So that are very wonderful because I explain British code, European code, ACI code, what they say about lapping. Okay, where the critical sections are. So that are very important. Okay, so this winds up this lecture, and see you in next lecture inshallah, that is related with the detailing of the slab system. Thank you for watching.